Hello everyone, I'm Siddharthan. Currently, we are in the sixth module of our hands-on machine learning course, and this sixth module is all about machine learning models and some important concepts related to it. So, in today's video, we are going to understand what is meant by model evaluation and what is the importance of this model evaluation when it comes to machine learning. Okay, so this is the agenda for today's video. Before getting started, in case you are watching my videos for the first time, in this YouTube channel, I'm making a hands-on machine learning course. And if you want to learn this course from the beginning, I'll give the link of my course playlist in the description of this video. You can check that out. With that being said, let's get started with today's video. So first of all, let's try to understand the workflow of a machine learning project. So the steps which we follow when we are working on a machine learning project. So the first step would be to collect the data that we want. So the data set that we want differs based on the problem statement that we have. Let's say that if we want to predict whether a person has diabetes or not, we need to train our machine learning model with diabetes data. And if you want to use machine learning in order to predict some house prices or car prices, you need to find data related to it. So the first step will be finding this appropriate model. So once we have this model, we need to do some pre-processing on this data. So this step is called as data pre-processing. So the reason for this is the raw data cannot be fed to a machine learning model. So we need to process this data in order to make it suitable to feed to a machine learning model. So once we process the data, we often do some data analysis to find some insights from this data so that we can use the features better for our machine learning model. So once we analyze the data, as we can get some important informations about the data that we have, the next step will be to split our data set into training data and test data. Okay, so this is one of the most important steps where we split the entire data into two sets of data, and we use this training data in order to train our machine learning model, and we use our test data to evaluate our model to check how well our model is performing. Okay, so once we split this data, we will feed the training data to a machine learning model. So in this case, I have just used a XGBoost regressor. So similarly, you can use any machine learning model. So you have a support vector machine model. So there is logistic regression. So there are a lot of different types of models, and we feed this training data to a machine learning model. So once we train our machine learning model, we will use the test data that we have splitted to a evaluation metric. Okay, so this evaluation metric is used to find the performance of the model. So it is used to check how well our model is performing, how many correct predictions our model is making, and so on. Okay, so this step is called as evaluation, and it is one of the most fundamental steps that we need to do when we are working on machine learning. So you cannot just train a machine learning model and you can use it to prediction. So we cannot do that. First of all, we need to understand what is the accuracy of the model, how well our model is performing. Only if the accuracy is good, we can use the particular model for our predictions. So this step is called as evaluation. So we need to understand one more thing here. So we know that there are two main types of supervised learning. So one is classification and regression, right? So each classification and regression, so both of them have their separate evaluation metric. So let's first of all try to understand about classification and regression. So classification is about predicting a class or discrete value. Okay, example male or female, true or false. So in this, we are just classifying the data. So it can be, as I've told before, it can be predicting whether a person has diabetes or not, or it can be predicting whether a person has heart disease or not. So in this case, we are just predicting two or three classes. Okay, so as you can see the example here, so male or female. So in this case, we have two classes, and true or false, it is also class. So we are just classifying the data. And regression is something where we try to predict a quantity or a continuous value. For example, predicting the salary of a person based on their work experience, or predicting the age of a person, or predicting the price of a product based on some features. So this is called as regression. So classification is about classifying the data into different classes, and regression is about finding a fixed value or some continuous value. So not a fixed value but a continuous value. So this can be a decimal or any values. So this is called as regression. And the evaluation metric for classification is accuracy score. So this is the most widely used evaluation metric for classification. And then for regression, we have evaluation metrics such as mean absolute error, mean squared error, etc. Okay. So in this video, let's try to understand what is about this accuracy score, and also we will understand about mean squared error. So different types of evaluation metrics are mean absolute error, mean squared error, etc. And in this video, let's understand about mean squared error. So first of all, let's try to understand about this accuracy score. As I've told you, accuracy score is used as an evaluation metric for classification problems. So this is the definition of an accuracy score. So this is very, very simple. In classification, accuracy score is the ratio of the number of correct predictions to the total number of input data points. Okay, so we just need to find the ratio of the number of correct predictions. So we let's say that we have trained our machine learning model. So once we train our machine learning model, let's say that we are using this model to predict a set of values. So let's say that there are about 100 values and we are trying to predict this 100 values, and out of this let's say that our model has predicted correctly for 50 values, and in this case the total number of data points that we have, the total number of input data points we have is 100 and the number of correct predictions is 50. So if you take the ratio, it is 0.5, right? So 0.5 means 50 percentage. So this is called as the accuracy score. So you can write the formula for accuracy score like this. So accuracy score is equal to number of correct predictions divided by total number of data points. So if you just multiply this particular value by 100, you will get a percentage. So if you just divide this number of correct predictions and total number of data points, you will get a decimal value less than 0. So if you multiply it with 100, you will get the percentage of this accuracy score. Okay, so this is just like finding a simple percentage. So let's try to understand this with an example. Let's say that we are predicting whether a person is diabetic or not. Okay, so let's say that we are using a machine learning model. So this particular machine learning model is trained with diabetes data, and now we are taking 150 data points. So the total number of data points that we have for this particular testing, so this is the test data. So we train our machine learning model with the training data, and we test or evaluate it with the test data. So the total number of data points that we have in test data is, let's say, 150. So out of this 150 data points, the model has predicted correctly whether the person has diabetes or not for 128 data points. So in this case, the accuracy score will be 85.3. So if you just plug in these values in this particular formula, it will be 128 divided by 150 into 100 percentage. Okay, so if you calculate it, you will get an accuracy score of 85.3 percentage. So this is how you can calculate the accuracy score of a model when it comes to classification. Okay, so this is the Python command or Python program which you can use in order to import the accuracy score function. So we don't have to do this manually. So we have a ready-made function in order to calculate this accuracy score, and this is present in the sklearn library in Python. So you just need to run this particular line from sklearn.metrics. So sklearn is the library, and in the sklearn library we have a module called as metrics. So this metrics module contains all the evaluation metric that we need. So from sklearn.metrics, import accuracy score, and this accuracy score is the function which is helpful to calculate this accuracy score. Okay, so you can also check out my other machine learning projects. So I have did several machine learning projects on classification as well as regression. So in that I have explained to you hands-on on how to find this accuracy score for a particular model. Okay, so you can also check that machine learning projects. I'll give the link for those project playlist in the description of this video, so you can also check that out. Now let's try to understand about mean squared error. So as I've told you, the accuracy score is used for classification problems, and the mean squared error and mean absolute errors are used for regression problems. So mean squared error is one of the most important and most widely used evaluation metrics when it comes to regression. So this is the definition of mean squared error. So mean squared error measures the average of the squares of the errors, that is the average squared difference between the estimated values and the actual values. Okay, so we can understand this definition better if we just look at this formula. Okay, so MSE represents mean squared error. So mean squared error is equal to 1 by n summation of yi minus yi cap whole square. Okay, so here we have two values. One is the estimated values. So estimated values is nothing but the predicted value, and then we have this actual value. So actual value is the true value, and estimated value is the one predicted by our model. So estimated value is yi cap and actual value is yi. Okay, so here what we do is we try to find the difference between the two values, the one predicted by the model and the true value. So we find this difference and we square this difference, and let's say we have 100 data points, so 100 test data points, and we are finding the predicted value for all these 100 data points. So we try to find the difference of the true value and estimated value for all these 100 data points, and we will get some value. So we will just summation this all these difference raised to the power 2. Okay, so we just find the difference and square this value individually for all these 100 data points, and we divide it by the total number of data points that we have. So in this case, the total number of data points that we have is 100. Okay, so In our previous video where I explained about loss function, I have explained you how you can find the mean squared loss in machine learning. So that step is actually similar to the mean squared error. So if you want to have a better understanding of this, you can watch that video as well, where I have clearly explained you how you can calculate this value. Okay, so in that video I took an example and calculated the mean square error or the loss value. So you can also check that out. So in this case, let's say that we are predicting the average blood sugar level. So in the previous classification problem, we took an example where we tried to predict whether a person has diabetes or not. So this is it is an example of a classification problem. Now let's say that we have a regression problem where we need to find the average blood sugar level of a person. In this case, this is not classification. We are just finding some actual value, some some continuous value or some number. Okay, so which is an example of regression. Let's say that in this case, there is a person and the average blood sugar level of that person is 140 milligram per deciliter. Okay, so this is the true value, and let's say that we have trained a machine learning model which can predict the blood sugar level, and this particular model has predicted the value to be 160 milligram per deciliter. So here you can see there is an error of 20 milligram. If you subtract these two values, so this is yi cap. Okay, so yi cap represents the predicted value, so I missed to include it. So this is yi represents the actual value and yi cap is the predicted value. So you just need to plug in the values here. So 140 minus 160. So we are squaring this value in order to neglect the sign convention. So if you subtract 140 minus 160, you will get an error value of minus 20. So we don't want these negative errors in our evaluation metric. So if you just have negative errors and positive errors, both of these errors will cancel out, and we don't want that. It won't be a correct metric. So we need to remove those signs. Hence, we are squaring the error. So this is one data point. So let's say that we have about 100 data points, as I've told before. So for these 100 people, we try to measure the blood sugar level using this machine learning model, and we compare these values, the values predicted by our model, with the values which are the actual values or the true values, and we subtract those difference and we square them individually, and we do that summation, and we finally divide it by the total number of values, where the total number of values in this case is 100. Okay, so you will get some mean squared error value. So this mean squared error value can be 1.5, it can be 5.3, it can be 10 point no something, or it can be any values. So when your mean squared error value is less, that means your model is performing better. So there is no fixed value where we can tell that if the value is 1, that mean squared error is good or something like that. So we cannot give a fixed number for a good value of mean squared error. If the value is less, then our model is performing better. If the value is 0, if the mean squared error value is 0, that means our model is making accurate predictions, but it is not possible in most of the cases. So the value that we get depends on the data set that we have, the problem we are solving. Let's say that we are predicting the blood sugar level of a person, and we try to calculate the mean squared error, and the overall mean squared error that we get is about let's say that it's about 10.5. So now we need to look at this magnitude of the data that we have. So 140 milligram and 160 milligram. So it is in the average value of about 150 milligram per deciliter. In this magnitude of 150, a difference or an error of 10 is kind of more. So you can, it's not very high, but it's kind of high, right? So this is I mean squared error value. But if you get a mean squared error value of 5 or 4, in that case, we have a very low mean squared error. So very low mean squared error value represents we have a very good model. Let's consider another case, and let's say that in this case, we are trying to predict the price of a car. And the price of the car can be 5 lakhs, 10 lakhs, or 20 lakhs. In this case, let's say that we get a mean square error value of 100 or 200. Okay, so 100 or 200 rupees. So when you think about the magnitude in this particular case, the magnitude is in lakhs. And when you have values in lakhs, you can have error values of hundreds or 200s, which is very less compared to it. So you cannot make a generalized statement of what is a good mean square error. So we need to look at the magnitude of the data that we have, and we need to compare it to get to understand what is a mean squared error. So it depends on this particular value. And the one thing which you need to note particularly here is that lower mean square error value means the model is performing better. So we want just lower values. So that is one main insight which we need to understand about. So we are just taking the estimated values or the predicted values as y cap and the actual values as ya, and we are just trying to find the difference between them, and we are taking the square of it, and we add all those data points and divide it by the total number of values. So that is given in this definition, where we try to find the average squared difference between the estimated values and the actual values. So this is the Python line which you can use in order to import mean squared error. So from sklearn.metrics import mean squared error. So you can use this particular line in order to import this function, where we have this ready-made function as mean squared error to calculate this particular value. And you can also check out my other regression machine learning projects. So I have done several regression machine learning projects like house price predictions and car price predictions, etc. So you can watch those machine learning projects to understand how to implement this squared error, mean squared error, and things like that. Okay, so that's it for this video, and I hope you have understood clearly about evaluation metrics in machine learning. So that's it for this video, and I'll see you in the next upload. Thanks for watching.